Hello everybody, starting from this video, we're going to learn chapter 3, the numeric description for the data. So before this video, what we focus on will be the visualization of the data. So we look at different charts and the tables, and we learn how to use the chart and table to summarize the relationship as well. So starting from this video, we're going to focus on numbers. And so you will see a lot of familiar concepts like mean, median, mode, standard deviation. And so as we went through those concepts, I hope you guys won't get bored, although you learn Stat 260. The main goal for this part is try to understand how to apply those statistics properly to analyze the business data. And also if you're your boss or even you start your own business and you are analyzing the data, where to start and what would be the important statistic numbers you need to get in order to get the right insight about your data. And of course, we're going to focus on the Excel part as well. And so all the videos after lecturing and will follow by a computer skill lecture. And also for the attendance chart of this week is also related to the Excel part as well. And so let's look at what we're going to learn from chapter 3. So in chapter 3, we're going to look at numeric measures, and I separate chapter 3 into two parts again. And there's a difference in part 1, we are focusing on the basic statistic, mean, median, mode, and the statistics you can use to measure the relationship. And when we move on to part B, and we will look at more broader statistics, such as how to measure the shape of your the data distribution and how to use the statistic to help you to find outliers from your data. So that's basically what we're going to cover. So first, in part A, and we're going to look at how to summarizing the data using numeric measures. Or in another way, what would be the essential data you should report if you try to use the statistics to analyze it. So to help you understand how to characterize your data, and I want to use this as example. So look at on this on these slides. So we have 3 circles, a blue, purple, and gray. Obviously, there are all 3 different circles, right? And so I hope you still remember if you take some geometry class from your high school, and you still remember how to use the compass to draw a unique circle. In order to draw a unique circle, you need 2 important values. So the first value is the center. So where is the location? So that center defines the location of your circle. And the second is the radius. So the 2 value will identify a unique circle. So for instance, the purple and the blue, they are located at the same location, but they are 2 different circles because their radius are different. And the purple and the blue and the gray, they're 2 different circles. Although they have the same radius, they have different center. Therefore, there are 2 different circles as well. And then the reason I point this out is because I want to help you understand what will be the important statistic you should report when you try to summarize a data set. So you have to report the statistic that is measured the central location. And then you're going to report the statistic that is used to measure the, we call the variability of the data. So given these 2 statistic value, without seeing your sample data, people will be able to understand how your sample looks like. Similar like here, without drawing the 3 circle, if you can tell people about the center and the radius, and people will be able to figure out how the circle should look like. And we try to use the same idea to describing our data. So ultimate goal is we try to use the statistics to help people understand the data we're analyzing. Therefore, we can look at what will be the statistic you can use to measure the center, and what will be the statistic you can use to measure the variability. Variability is similar like what we talk about here, radius. So that's what we're going to look at. First, measure the location and measure the variability of the data set. So if we try to measure the location, we're going to look at, we will have 4 possible statistics you can use. Mean, median, mode, geometric mean, and sometimes we have a weighted mean as well. So in this class, we will focus on the first 3, mean, median, mode, and I fully understand that you already learned for how to use a calculator to calculate 3 values from the stat 260. Therefore, in this class, we will focus on the advantage and the disadvantage of these 3 statistics, and also how to use Excel to generate the values. So keep in mind, I will give you some example to help you understand why mean median mode will be used in different situations. And before we look at each individual one, and I want to mention that if in this case, if the measure are computed for data from the sample, and we are called the sample statistics, and if the measure are computed for data from the population, they are called population parameters. And actually, we are using different notations to distinguish the sample statistic from the population parameters. Therefore, pay attention on the notation. And sometimes I will ask you a question in the exam to make sure you understand the different notations, because it's basically how we, when you talk to any well-trained statistician or business analysis, they will be understand the notation. Therefore, we kind of require you to remember those notations. So starting from mean. And so perhaps the most important measure of the location is the mean. The mean provides measure central location, and the mean of the data set is an average of all the data value. And the simple mean, I guess I pay attention on the notation. And so the simple mean is using this special notation called the X bar. You're going to see this notation again in chapter 14 and 15, and hopefully you will retain this notation in your brain. And then we're going to use it again. So X bar is the sample mean. If we talk about population mean, and we're using this Greek letter pronounced mu. So mu is for the population mean, X bar is for the sample mean. So this is the universal notation. No matter you talk to no matter you talk to anybody from other country who have the statistic background, if you don't know the language, like you don't know Chinese, you don't know how to speak Japanese, if etc. If you show them this notation, they know what does that mean. So therefore, I have requirement that is you have to remember these two notation: X bar for simple mean, mu for population mean. So now let's look at how we calculate. So to calculate a sample mean, we're using this formula. So the numerator is this is called summation. So you sum summation, and xi is representing each individual observations. So you sum all the observations together, and then divide by this n is the sample mean. So that is how we calculate X bar. And again, in this class, we're going to focus on Excel. The reason I still showing this formula because later I will show you the example to help you understand why sometimes the mean just doesn't work well to capture your central location of the data. So regarding the population mean, the calculations are very similar, except the notation. We're using the mu, as I said, is for population mean. And then again, we sum all the observation in population together, and then divide by the capital N, which is representing the population mean. So this is the population mean. This is the mean. Now I want to show you the example. Again, I show you the example is because I just want to later to help you identify those differences of the advantage and disadvantage of the data. So let's see the first example. My observation have 1, 2, 3, 4, 5. I just try to make it easier. And so based on the notation, so we have okay, so let's just treat it as a sample mean, okay? X bar equal to the summation so the summation xi and then divide by n, right? That's what we see on the slides. So basically what we would do is 1 plus 2 plus 3 plus 4 plus 5, and then divide by, we total have 5 observations, divide by 5, right? So then this is gonna give us the value. So this will give us 6, 12. Oh, give us the value of 3, right? So this is the Sample mean. So this is how we calculate it. So I want you to imagine. Let's see, we have observation instead of 1, 2, 3, 4, 5. We end up 1, 2, 3, 4, 100, right? So if that's the case, so instead of plus 5 here, we're going to end up with 100. So then what would be our answer? So let's see the. So let's see, okay? So we'll do 1 plus 2 plus 3 plus 4 plus 100. And then divide by 5. Okay, we end up 22. So remember, this statistic we are using is supposed to capture the central location of my data, which means all the data is supposed to not live too far away from this number we calculated. So in the first example, it makes sense. So all the numbers are very close to my 3. However, look at the second case. So the center is 22. And then if you look at all my observation, everyone is very, very far away from 22. So which means the 22 is not a qualified statistic you can use to measure the central location, which is where most of my data is located. So what's the problem here? Obviously, you notice that the difference happened because I changed in my last observation from 5 to 100 and compare 100 with the rest of the full observation. It is extremely large, right? Extremely large. Therefore, you are being a back to the old time. The statistician who created the mean, they noticed that, oh wait, it doesn't work well. Can we find another statistic that we can use to measure our central location so that it will not be affected by this extremely large or sometimes will be extremely small value, right? So what will be the best way to do it? Therefore, the statistician came out with the second statistic that is called median. So the median of the data set is the value in the middle when the data items are arranged in ascending order. So basically, you order the data first, and then based on the location, you look at, okay, which data is sitting in the center. So that would be my median. So that's what I said. Whenever a data set has extreme value, the median is a preferred measure of the central location and the application in the real world. And so such as annual income and property value data. And so you should consider use the median. So back to the very beginning of the semester, when I record the first video, I asked you guys about the question on, so how about you go out to 50 different cities, collect 100 people's income, and then ask you to rank in the city based on the income level. So as some students are thinking, oh, average, but obviously you might have outlier in your data, right? In order to properly capture the characteristic of the data, you should use the median based on the median to rank in the city, based on the median to rank in the city. So let's look at the same example we just saw before. So instead of using the average to capture the data, the central location of the data, how about the median? So look at the first case. I already sorted it by from the smallest to the largest value. Therefore, I don't need to resort it ascending order. So which number is my median? Yes, the median is 3. So look at the second example. What is my median? Again, I already sorted based from the smallest to large number, so you don't need to reorder it. So the number in the middle will be 3. So 3 definitely is more proper than 22. So majority of the data is close to 3. And so instead of 22, none of the data is close to 22. And so one more example, and then we're going to move on to the next statistics. So in this situation, it's easier to identify what is my median, right? 1, 2, 3, 4, 100. So we have odd number of observations. So you only have one observation in the center. So how about this case? 1, 2, 3, 4, 5, and 100. So what is my median? So in this case, the median will be, we have 6 numbers, right? So we have even number of observations, So we have two numbers located in the center. In order to correctly calculate the mean, we just need to find the average of these two. So 3 plus 4 and then divide by 2. So that gives us 3.5. So our median in this case will be 3.5. So mean, median, mode. So the last one is the mode. And the mode of the data set is a value that occur with the greatest frequency. So it's very, very simple, easy to get it. So the greatest frequency can occur two or more different values. So if the data have exactly two modes, the data have the bimodal. And if the data have more than two modes, the data are multimodal. So here in my class, I want to emphasize is that if you have more than one mode, and we prefer not use mode. Again, the mode is supposed to use to capture the central location. Ideally, we should only have one central location, but in some situation we might have two. I prefer to use mode when we only have one mode. So go back to my example again. So if you look at all three cases, the mode is not exist because every observation's frequency is 1. So everyone is unique. However, if you look at this case, so if my observation is 1, 1, 1, 2, 3, 1, 1, 1, 4, 3, 4, and 6. So in this case, what is my mode? I only have one mode, that is 1, because 1 is the observation showing most had the highest frequency showing up. So 4 ones and 2 threes. So therefore mode is 1. Okay, and so this is the mean median mode, and this is a very important table I want you to bear in your mind. And there is many multiple choices in the weekly quizzes, and the exam is related to this part. Again, I don't want you to remember the formula, the manually calculation formula, but I want you to definitely remember the advantage and disadvantage of this measurement, because it's literally going to affect you in the long term, in the real world, regarding how you select the best statistic to measure the central location.